All right, guys. Here we go. So, sorry for the delay in this one. It's been one of those funky technology days, and if you were in tutoring, you could tell by the way it was delaying and everything else. So, when we're dealing with derivatives of sine functions, sine and cosine, so we're going to work our way through the trig functions. These are the two rules you got to remember right here. The derivative of sine is equal to cosine of u times u prime. Unfortunately, I'm just throwing this out there, calculus doesn't allow you, if you take the test here at the school or out at Crespi, they're not going to give you the formula sheet, so you're going to have to know some of these. So just keep working with them, using the formula sheet, practice it enough so you remember it. And then the other one is the derivative of cosine of u is negative sine of u times u prime. So we've got to kind of mess with things just a little bit. So if we look at that first example at the top of the worksheet, I'm just going to do these, and then we're going to do some more tomorrow in class, just because we probably need to practice these. So I'm going to change this to the sine of u, because u is going to be equal to 5x, and so u prime is equal to 5. So if I take my idea, so I let u equal 5x and u prime is equal to 5, if I'm taking the derivative of the sine of u, so I'm going to take the derivative of the sine of u, I'm going to get a y prime equal to cosine of u times u prime. Well, I can substitute all my pieces back in, so my answer is the cosine of 5x times 5, and if I move the 5 out front, cosine of 5x. Okay? So that's kind of how we tackle it. So we're kind of doing that idea of the u substitution I showed you guys the other day. So let's look at this. So I'm going to let let u equal 9x. That means u prime is equal to 9. And so my y prime is equal to the cosine of u is equal to the negative sine of u times u prime, which in turn, plug everything back in, negative sine of 9x times 9 gives me negative 9 sine of 9x. That is my derivative. So, when we're working with these things, they'll just start layering it up on you guys here. And so, that's our next one here, which is our y equals the sine of sine to the 4th power x. I'm going to erase this. I just realized I want to do this in the middle so you guys can really see it. So, all right. So if we look at this, and we have y equals 3 sine of 4x, right? Okay, so let's just kind of rewrite this. I don't like them like this. I never have. So personally, I like to write it like this. All right? And now I'm going to say, so these mean the same thing. I just like this better. It creates a cleaner look to me. So I'm going to say, okay, I'm going to make this u, I'm going to let the sine of, I'm going to let u equal the sine of x. Therefore, u prime is equal to the cosine of u times u prime, which is really, so it's the cosine of x times 1. Okay, so this is my u prime. So now, let's work with this here. I have to take the derivative of the outside, which is going to be 4 times 3, 4 times 3, times, and we got to subtract one off of there, times the derivative of the inside, u prime. So now if I clean all this up, I get 12 sine of x cubed times the cosine of x. Okay? There we go. So again, it's going to be keeping track of deciding what you're going to let u equal and u prime equal. So basically what we did here is we had a equation that's going to use our trig identities, but it was a chain rule. I turned it into a chain rule problem where you take the derivative of that whole thing times the derivative of the inside. The derivative of the inside, we used our derivative of trigonometric functions to find u prime. And since there was no number or exponent on this x value, it's really times 1, so we just left it just like this. This 4 came from moving the 4 down. This 3, we subtracted the 1 off. And then we've got our equation that looks 12 times the sine x cubed times cosine of x. So that is how you work with sine and cosine trig functions and derivatives, guys.